Okay, let's have a look at algebra. Algebra involves letters, or pronumerals, or variables. So you might have something like A, which stands for a number, or 3x, which stands for 3 lots of a certain number. Now, if we have things like 7 or a -5, they're fixed. These ones are called constants. Whereas the other ones, depending on what we make x or what we make a, they can change or they can vary, and they are called variables. Also called pronumerals because they stand in place for a numeral. Now, when we've got variables, we have things called like terms. If I have a or 2a or -7a, they are all like terms because the letter part is all the same. If I have something like x squared, or a half x squared, or 17x squared, they are also like terms because the x squared part, the thing with the letter, is all the same. So yes, these are like terms, these are like terms, but if I had something like 2x, and 2x squared, the letter part, remembering that x squared is really x times x, is different to this x, and this one hasn't even got an x. So no, these ones are not like terms. We can even have things like AB, 6AB, and 9BA. They are like terms because the letter part, A times B, A times B, B times A, but because it's multiplication, it's exactly the same thing as A times B. So they're like terms as well. If you want to add with algebra, you can only add like terms. So if I have something like this, if I have 3 A's and I want to add on 2 A's, I end up with 5 A's. Or if I've got 16C and I want to take away 3C, then 16 minus 3 is 13. I've got 13 of those variables, or 13C. But if I had something like 8A plus 7B, they are different. So I can't simplify that any further. So my answer is exactly the same as what I started with. They're not like terms, so they can't be simplified. But with multiplication and division, we can do whatever we like. If I have 16A and I times that by 2B, I can multiply the numbers as per usual. 16 times 2 is 32. And then A times B is AB. So that simplifies to 32AB. Just like if I had 10xy and I divide that by 2x, I know that 10 divided by 2 is 5, so 5 is on the top. Oh, but then I've got x's, they can cancel, so they're gone. I'm left with a y on the bottom. It's really over 1, but dividing by 1 doesn't change it, so my answer simplifies to 5y. If I've got an expression like this and I need to simplify it, it means gathering up anything that are like terms. So I have 13x's there, I go along the line, there's 4x's there, but it's actually a -4x. So if I add those two things together, if I have 13x's and I take away 4x's, I end up with 9x's. Then I go to the numbers. There's a +7 there and a +2 there. So +7 plus 2 is +9. So this algebraic expression simplifies to 9x plus 9. If I try one a little bit harder, maybe 7ab minus 10 minus 12ba plus 3. Once again, I look for like terms. I've got a 7AB here. I go along the line, there's an AB, they're beside each other, so that is also a like term with 7AB. Now if I have 7AB and I take away 12BA, it's the same as taking away 12AB, so that's minus 5AB. I can write BA, but AB's alphabetical, so maybe I'll choose that way. Then what's left over? I've got a minus 10 and a plus 3. I've got a negative 10, I have to come up 3, I end up at minus 7. So that expression simplifies to minus 5AB, take away 7. Then we have something called expanding. If I've got 3 outside a bracket with x plus 2 in it, that means that that 3 has to multiply with the x in the bracket and with the 2 in the bracket. So firstly, the 3 multiplies with the x to give us 3x, and then the 3 has to multiply with the positive 2 to give us 3 times 2, which is 6. So that bracket expanded gives you 3x plus 2. We'll try another one. If I had 8a outside of 3 minus 2a, once again, the 8a has been multiplied with the first thing in the bracket and then with the second thing in the bracket. So 8a times 3, 8 3s are 24, but it's got an a next to it, so it needs an a there. Then 8a times 2a. Firstly, the numbers, 8 times 2 is 16, but it's 8 times minus 2, so it's minus 16. And then a times a is a squared. We can also do the opposite of expanding, and that's called factorising. So if you can remember that factorise, bracketise, then if I have something like 10x plus 20, and I'm asked to factorise that, I have to end up with something outside a bracket and then something inside the brackets. So I look at those two terms, the 10x and the 20. What have they got in common? 10 goes into both of them, so the 10 comes out the front. Then, what do I have to multiply that 10 by to get 10x? I need to multiply it by an x. And then, what do I have to multiply this 10 by to get 20? 10 times 2 is 20, so the 2 goes there, but it's actually a plus 20, so 10 times what gives me plus 20? It's a positive 2. So 10x plus 20 factorises to 10 outside of x plus 2. They can get harder. We might have something like 3xy minus 15x squared. I have to look at both of those terms. 3xy and 15x squared. What have they both got in common? Well, 3 goes into both of them, so the 3 can come out the front. They've both got an x in them, so the x can come out the front as well. Then I have to figure out what goes in the bracket. So, from the first term, I've got a 3x out the front, but I want a 3xy. So what do I have to multiply that by to give me that term? The only thing that's missing is the y. Then, I've got the 3x out the front, and I want a minus 15x squared at the back of the bracket. There's a minus sign, so that will go there. 3 times what gives me 15 is 5. Now this is 3x, but I want 15x squared. So x times x gives me an x squared. So that one factorised fully goes to 3x outside of y minus 3x. Sorry, y minus 5x. The next thing we're going to look at is algebraic fractions. It combines algebra and fractions. So, the most basic of them all. Here, the denominator is 5 in both of them. Because they're out of the same number of parts, we just add the top two things together. So x plus 2x is 3x, and we're dividing by 5 parts, it stays out of 5. So x over 5 plus 2x over 5 simplifies to 3x over 5. if I'm going to multiply two fractions together, top times top over bottom times bottom. But the thing we need to look at first, is there anything we can cancel? I can see a 2 there and a 4 there. So 2 into 2 goes once, 2 into 4 goes twice. What else can I see? I can see 5 and 15. 5 into 5 goes once, 5 into 15 goes 3 times. But there's also an x. X into x goes once, x into x goes once. So what am I left with now? Across the top I've got 1 times 3, which is 3. And along the bottom I've got 1 times 2 times y, which is 2y. So that fraction simplifies to 3 over 2y. Okay, dividing by fractions. Easy as pie. Flip the second end, multiply. So first thing we need to do is keep the first fraction. Flip the second fraction, so the 9y comes on top, 16x on the bottom, x squared y on the bottom, and we change the division to a multiply. Multiplying fractions, no big problem, top times top over bottom times bottom. But cancel first will make it easier. There's an x which will cancel with that x. There's a y which will cancel with that y. What else happens? Oh, we've got 8 into 8 goes once, 8 into 16 goes twice. Then 3 into 3 goes once, 3 into 9 goes 3 times. Don't think there's anything else. Let's have a look what we've got. So we've got 1 times 3 times y on the top, which is 3y. On the bottom we've got 1 times 2 times x squared, which is 2x squared. Nothing else can cancel, so that's what we're left with. Now be mindful that you can cancel anything on the top with anything on the bottom when you're multiplying. They don't have to be directly above or below each other, like the 8 and the 16. The 8 can be over there and the 16 can be over here. Okay, so as long as one's on the top and the other one's on the bottom.